Alright, so we are going over section 26B, right? The homework from 26B. Alright, we're going to do number 2. So let's write this thing out. Alright, here it is. That's crazy looking, isn't it? Oops, that's a crazy looking S. Alright, try it again. Solve. That's what they say to solve for. So we're solving for K, obviously, since that's the only variable. Let's do
K plus 5 squared equal X.
Yeah, good idea. That's what I'm going to do. I'll tell you what. Let's do this. Let's make this a different color, just so it stands out, just so you can kind of see what we're talking about here. And let's make that stand out to that. All right. So look at this thing right here, the way I've got it written. Let's go back to white. If you look at this, it looks real complicated at first. But see the stuff that I have in blue? It's kind of like this. It kind of looks like 6x squared. But instead of the blue stuff, what did I replace the blue with? Just an x, right? This is an x, isn't it? Right? And look, that's the same exact thing as this, so that could be an x as well. Would you agree with that? So what I'm going to do, and I'm going to say let x equal this thing right here in blue, which is k plus 5, that quantity is squared. That way, once I do that, then it makes it look a lot easier. Okay, then it looks like something I can actually factor. I can actually solve for x. It doesn't look as crazy and weird looking as what we had before. So it's minus 17. Remember, we let x equal this thing, so we just call that an x. Plus 5 equals 0. Does this thing factor or not? It does factor. Just to save me some time, you want to help me out? Actually, probably is pretty easy, isn't it? So it's 2 and what, 3? And then minus 5 and plus 1. Is that right? Okay, so let's see if that works. We know the the first and the last work. Let's try the outside. That's 2x minus 15. That's not going to work though, is it? Oh, it's both minus. Yeah, that was my fault because I don't know, for some reason I saw that minus. I should have looked here, right? This times this is positive, and they add up to be negative. So yeah, that'll work. That's my fault. So the outside is negative 2x. The inside is negative 15, which is negative 17. All right, so that factor is nice. Thanks for your help on that. And now we can solve for x. Remember, both these things are being multiplied, and your answer is 0, so we set them both equal to 0. You just have to go back and watch the original lesson on why that happens. Alright, and now we solve for x. Add a 5, divide by 2, so x is 5 over 2. Add a 1, divide by 3, so x is 1 over 3. But we don't circle that, do we? That's not our answer. Remember what x is equal to. X is equal to this thing right here, k plus 5 squared. Well, here's an x right here. Let's change this to another color. Remember what x is equal to. K plus 5, that quantity, squared. So let's do this. So k, instead of x equals, we're going to put k plus 5 squared equals 5 halves. And then we can solve for k. We just did another substitution, didn't we? We substituted an x in here at the beginning to make it easier so we could solve for it. But then when we get x by itself, once we've actually solved for x, we're going to have to replace it back into what we let x equal. Hope that makes sense. So we're doing two substitutions. You put an x in here to make it real easy, but then you got to put this back in for the x, and that's exactly what we're doing. So instead of x equals this, we're going to put k plus 5 squared equals this, because x and k plus 5 squared are the same thing, because we let them equal to each other. And we'll solve for that in a second. Let's do the same thing here. So instead of x equals 1/3, what did we say x is equal to? K plus 5 squared. So instead of x equals 1/3, it's k plus 5 squared equals 1/3. It's just substitution, okay? We just substituted it back in because we let x equal k plus 5 squared, and we just replaced that x with that. And now we can go ahead and we can actually solve for k at this time. What we're going to do right now is get rid of this squared. How do we get rid of a squared? Square root it. That's right. It's going to go away, and then we put a square root over here. Make sure you put a plus or minus. And then we're going to subtract a 5. So k equals negative 5 plus or minus the square root of, let's do it like this, square root of 5 over 2. But we're not going to leave our answer like this. Why is that really not acceptable to leave your answer like this?
There's a thing in the
There's a square root in the
square root.
denominator. That's right. There's a square root in the bottom. Okay, and you look at this and you're like, well, wait a minute. It's just a fraction in a square root. But yeah, that would be the square root of 5 over the square root of 2, wouldn't it? All right, so we're going to be a little bit picky on this because I promise you there will be teachers next year, whether you take another math class here or you go to college and you take a college algebra class or something like that. You'll have teachers that are going to want you to rationalize the denominator. Some teachers might not care about that, but some teachers will. So if they don't care, then you're good to go. You can just leave it like that. But if they do care and they want you to rationalize the denominator, I want to make sure that you know how to do that so that when you get to that point, you're able to do it. So this is the same thing as the square root of 5 over the square root of 2. Let's just work with this thing right here before we add it to this negative 5. All right. How do we get rid of that square root of 2?
They multiply everything by square root of
Yeah,
2
multiply
over
the,
square root of 2.
yeah, multiply, well, not everything, just this fraction right here. We're not going to multiply this fraction by it, just this fraction right here. So basically, we haven't changed the value of this at all, have we? We've just changed, we've just made it, we've just multiplied by a 1, right? And that really didn't change that. But what it did, it got rid of the square root. We'll show you. We'll keep this negative 5 over 1, put the plus or minus there, and let's see what we get now. Look at the bottom. The square root of 2 times the square root of 2 is just 2. We've done that a bunch of times, dozens of times this year. We've done that kind of thing, literally dozens of times. Look at the top. Square root of 5 times square root of 2 is just the square root of 10. Now, we can find a common denominator, and we can write the answer the way I read it off to you. The common denominator would be 2. There's a plus or minus in the middle. So 1 times 2, negative 5 times 2, which actually, to tell you the truth, if you wanted to keep it like that, I'd be perfectly fine with that. All right, because that's kind of simplified, but I'm just showing you how the book writes the answer. Okay, this is why I read the answer off the way I did, because this is what the book gave. So 1 times 2 is 2, negative 5 times 2 is negative 10, and this didn't change right here, so this isn't going to change. Oh, actually, what am I doing? That was dumb. That's just the square root of 10. All right, that's what I read off to you. Okay, and that's what the book answer is. I would be fine if you would have kept it like this. Okay, I wouldn't be fine if you kept it like this, with a square root in the denominator. All right. So when you get an answer, you must simplify your answer. Yes. Yeah, we got to do the other side. We're not done, but I'm just saying this side right here. Everybody good with that? All right, this should be pretty much the same deal, right? So let's do this a little bit quicker. So we're going to take the square root of both sides, and then we're going to subtract a 5. So it's negative 5 plus or minus the square root of 1/3. Now let's just simplify it. So it's negative 5 plus or minus. Now look at this. The square root of 1 is just 1 over the square root of 3. That's the same exact thing. Now we got to get rid of that square root of 3 on the denominator. So we've already seen it once. So we multiply the bottom by the square root of 3 and the top by the square root of 3. And then it's negative 5 plus or minus. This is 1 times square root of 3, just square root of 3. And then on the bottom, square root of 3 times square root of 3 is just a 3. We'll put that over 1. Find a common denominator, which is 3. 1 times 3, negative 5 times 3 is negative 15. Plus or minus, that didn't change, so this doesn't change, and there you go. So it's actually 4 answers, isn't it? Right? This is 2 answers, right? With plus or minus, and this is 2 answers, so there's technically 4 answers altogether. Make sense? Well, I believe if you can do that one, you could probably do the rest of them. What was the other one? 8? Okay. Alright, so this is 6x to the 2/5 plus 5x to the 1/5 plus 1 equals 0. Alright. Again, it says to solve. And this is the one where we're going to... This doesn't look exactly like we want it to look. It's pretty close, but not quite. Because we want it to be what? 6x squared plus 5x plus 1 equals 0, don't we? So instead of this being just a 5x, what is it? It's a x to the 1/5. So I'm going to let... Actually, I'll tell you what. Let's do another letter. Because they start off with x here. They usually start off with another letter, and we let x equal something. But let's do this. Let's say let a equal. Is that all right? Just to use a different letter instead of x for both of them. So let a equal what? X to the 1/5. So whatever number that is right there, that's what we're going to let our variable equal. All right, it works out every single time, doesn't it? Whatever that one in the middle is, right there, next to that coefficient, that's what we let our variable equal. So that's really important that you do that. So now instead of x's, we're gonna use a's in this one. Now you could have picked any letter that you wanted to. I just happen to pick a. So what's this going to be then? This is going to be 6. Watch. It's x to the 1/5 squared, isn't it? So this is 6a squared plus 5a, right? Because I let that equal a, plus 1 equals 0. All right. This looks like it factors, doesn't it? What do we got? 3 and 2. Does that look like it works? Is it 6 and 1? Okay, good. Glad you told me. Just to make it a little quicker. And you could have tried, you could have tried 3 and 2 and found out it didn't work. Alright, but let's try 6 and 1 and put a 1 here and a 1 here. Does that... No, that's not going to work. I think it is 3 and 2, isn't it? I think it's 3 and 2. Let's try it. Put a 1 here, 1 here. Because watch, when you add the outside and inside, the outside is 3a and the inside is 2a, and that's 5a when you add them up. Agreed? Yeah, I think I did that right, didn't I? That's a plus. Set them both equal to 0. I'm going a little quicker now because I did all my explanation on the other problem. And now this is a lot easier solving for a on this one. Subtract a 1 divided by 3. So that's negative 1/3. Subtract a 1 divided by 2, so that is negative 1 over 2. Actually, it's about the same difficulty level. Now remember what we let x equal. We let x equal this thing right here. So, actually let's put it so I can see it. Right. So a is equal to x to the 1/5. So instead of writing a equals this, we're going to write x to the 1/5 equals this thing. We're going to do the same thing here. Instead of a equals negative 1/2, we're going to write x to the 1/5 equals negative 1/2. All I did was replace that a with the x to the 1/5 like I originally said was equal. That's all we did. Hope that doesn't confuse you right there. And now we have to just solve for x now, don't we? How do we do that? If it's to the 1/5 power, how do we get rid of a 1/5 power? Not square root it, but take it to the 5th power. That's right. Because watch, if I take this to the 5th power, what happens? They cancel each other out. 1/5 times 5 is a 1, so I got an x, don't I? So that means I got to take this to the 5th power as well. Let's just take a look at the sign. I have a negative to the 5th power. It's an odd number, right? So when I have a negative to an odd number, it's always going to become negative. If it was to an even exponent, it would come out positive. All right, so that's what I take care of first. Then it's 1/3 to the 5th power, which is going to be 1 to the 5th over 3 to the 5th. Well, 1 to the 5th is 1. What's 3 to the 5th? I don't know. It's like 81 times 3. 243? I think that's right, isn't it? I think I did my math right. Because I know 3 to the 4th is 81, and then times 3 again. Yep, there's a 3 and a 24, yep. So there's one answer. Let's do the same exact thing here. What do we do with this? We take this to the 5th power, so we take this to the 5th power, and so x equals, again, negative to the 5th is a negative, 1 to the 5th is 1, 2 to the 5th, I think that's 32. And there's your answer right there. Okay? Well, that is recorded, so you can always look at it a little bit later. Let's see. Let's just do 9 real quick. faster than you did the other ones. Is that the one you did ask about 9, right? Okay, 50 x to the negative second plus 55 x to the negative first. Now it says equals 90, but I'm going to put minus 90 equals 0. Hopefully you recognize that. All right, just to make it a quadratic. Look at this. This is when I want to do that let stuff, right? So I'm going to let, now it's already an x, so let's make it another letter. Let's make it a. Let's let a equal x to the negative first. So what I'm going to do is I'm going to replace this with an a. So this is going to be 50. Yeah, I was thinking of something else, but yeah, this is going to be a squared plus 55, just a, minus 90 equals 0. Now, before I try to solve for a, I see something. Do you see something that's in common with all three of these? 5 goes into all three of them, doesn't it? All right, so just to make it a little easier for myself, let's divide everything by 5. So what's that going to give us here? It's going to give us a 10a squared. If I divide this by 5, that gives us an 11a. If I divide this by 5, what's that? 18 equals 0. Now that might make it a little easier to factor, wouldn't you think? So hopefully these, I think all these factor, don't they? Have you tried it? So 10, I don't know, what are you going to use? Let's use 5 and 2. And this is going to be a positive and a negative. I don't know, let's just use 9 and 2. Let's see if that works. So let's see if it works. Do the outside and the inside. So the outside is negative 10 plus 18. That doesn't work, does it? Let's use 6 and 3 instead. Right here. That's negative 15 plus 12. Nope, that's not going to work. Let's try. Did anybody use these numbers? Probably nobody did they? Let's try 3 and 6 right here. That's negative 30 plus 6. Nope, that's not going to work. 9 and 2. Did we try 9 and 2 already? Or did we try 2 and 9? Did we try 9 and 2? Yeah, I think we did 9 and 2 already. Did we do 2 and 9? Negative 45 plus 4? No, that sure isn't going to work. Maybe my 5 and 2 is not good. Did I use everything for 18? 6 and 3, 9 and 2, right?
Switch it so it's 2 and 5, maybe?
Let's try 10 and 1. Because I think by switching the other ones. Let's try 10 and 1 right here. And let's try, I don't know, 6 and 3. Is that alright? Negative 30 plus 6. Nope, that doesn't work. Let's try 3 and 6. 3 and, no, that's negative 60 plus 3. That's not going to work. Oh, no. Let's try 9 and 2. Let's put the 9 here and the 2 here. That's negative 20 plus 9. I think we're getting somewhere. Let's do this. Let's change the positive and the negative. Let's make that positive and that's negative. So that would be, yeah, there we go. 20 minus 9, that's 11. Whew. We got it, didn't we? Alright, sometimes you get it quick, and sometimes you got to try a whole bunch of stuff. And we actually got it. So, what do we do now once we figure that out? Set them equal to 0, right? And so add a 9 to both sides and divide by 10. So a is equal to 9 over 10. And then just subtract 2 from both sides. So a is negative 2. And we're almost there. Remember, we got to go back to this, right? We want to solve for x. So a is equal to x to the negative first. So this would be x to the negative first equals 9 over 10. And this would be x to the negative first equals negative 2. We talked about this on Friday. In order to solve for x to the negative first, you could take this to the negative first, or you could realize this just means the inverse of x, doesn't it? So if I take the inverse of the inverse, I've got x. What do I do when I take the inverse of something, though? I flip it, right? So this is going to be 10 over 9. Is this answer right? Okay. And then if I do the same thing here, if I take the inverse of that, I get x. If I take the inverse of that, I get negative 1/2. And that should be my answer. Alright, so the hardest part about that was just factoring this thing right here. And you might have got lucky. You might have tried 10 and 1. But usually I try to split this number a little more evenly. But in this case, it didn't really work that way. There we go. Alright, that's the worksheet. That's 2.6b. Now we got a few minutes. We got to start on 2.6c.